Hello everyone, I welcome you all in the online lecture series of Environmental Engineering 1. Today's topic is the water softening methods. In the last lecture we have seen filtration and the disinfection of water. Now in the today's lecture we are going to see the introduction of water softening, then the necessity of water softening, water softening methods, lime soda method, ion exchange method, desalination, reverse osmosis process, electrodialysis, and fluoridation and defluoridation. We shall begin with the introduction of the water softening. So the process of removing the hardness of water is called as water softening process. This is defined as the removal of the hardness ions in the water. The hardness in the water is due to presence of calcium and magnesium ions. We know that there are two types of hardness: temporary hardness, or which is also called as a carbonate hardness, and a permanent hardness, which is known as non-carbonate hardness. The permissible limit as per Indian standard 10500/2012 for the hardness as CaCO3 for drinking water is 200 mg per liter. So we should reduce the hardness of water we should be less than the 200 mg per liter. Softening may be done by the water utility at the treatment plant or by the consumer at the point of use. So it may be used, it may be done at the water treatment plant itself, or you can also soften the water at the consumer level. Many water softening equipments are available in the market. Temporary hardness is due to carbonates and bicarbonates of calcium and magnesium. So as we have seen, there are two types of hardnesses, temporary and permanent. So the temporary hardness can be removed just by boiling the water. Now why there is a necessity of water softening? So the main reason for the water softening is reduction of soap consumption, then lowered cost in the maintenance of plumbing, and the improved taste in the foods prepared. So we know that because of hardness it can cause the rusting of the plumbing, or the rusting of the pipes, or the corrosion of the pipes, which is not good as far as the service life of the plumbing pipes are concerned. Also for the reduction of soap consumption, and if we soften the water it will improve the taste in the foods which is prepared. So in the diagram we can see that the basically hardness and softness is what it is called or it is caused because of calcium and magnesium ions. If we separate these ions from the hard water, then the water will get soft. Now we have seen that the temporary hardness can be removed just by the boiling of water. So we'll see how the temporary hardness can be removed. So CaCO3 is, that means calcium carbonate, is slightly soluble in the water. So it is usually exist in water as a bicarbonate. There will be a precipitation of CaCO3 and CO2 will get released. So if there is a hardness, and we know that the temporary hardness is a carbonate hardness, so if the CaHCO3 twice, if we heat the solution of CaHCO3 twice, then the CaCO3 will be precipitated and the CO2 or carbon dioxide will get released, plus H2 will be there. So in this type, we can remove the temporary hardness just by boiling the water. Now, as far as permanent hardness is considered, there are two types of or two methods of water softening. First method is lime soda method and the second method is ion exchange method. So we'll go one by one. First we'll see lime soda method. Firstly, the calcium carbonate hardness is in the form of calcium carbonate, bicarbonate. This is removed by precipitating it in the form of calcium carbonate, that is CaCO3. Basically lime soda, in the lime soda method there are 4 steps. First we have to remove the carbonate hardness, which is in the form of calcium bicarbonate, and the reaction which takes place as the CaHCO3, that means bicarbonate, plus CaOH twice, which gives 2 CaCO3 which will precipitate and 2 H2O will be there. So there will be a calcium carbonate precipitate that will be formed, and we know that calcium carbonate is the soluble in water, therefore the hardness will get removed. Secondly, the calcium non-carbonate hardness is because of chlorine, SO4 twice and NO3 minus ions. So these can be removed by adding the soda ash, and therefore the name of this method is given as lime and soda ash. So we have to add the soda ash into it, and the chemical formula of the soda or caustic soda is Na2CO3, sodium carbonate. Okay, so the reaction with calcium sulfate will be CaSO4 plus Na2CO3. If we add the soda in the calcium sulfate, then you will get the CaCO3 precipitate plus twice NaCl. NaCl means the sodium chloride, which is soluble in the water. So in this way we can reduce the hardness which is caused by because of calcium non-carbonate hardness. Okay. Thirdly, or the third step is carbonate hardness of magnesium is in the form of MgHCO3 twice, and this is precipitated in the form of MgOH twice. So the reaction will be MgHCO3 twice plus calcium hydroxide, which gives the precipitation of magnesium hydroxide plus CaCO3, which is highly soluble in the water, plus 2H2O. So in this way we can reduce or remove the hardness which is caused by because of magnesium. And lastly, the magnesium ion is paired with chlorine ions, then SO4 twice and NO3 minus. This can be removed by adding the soda ash or combination of lime and soda. Here lime will precipitate Mg2 plus and MgOH twice, but will addition also produce calcium non-carbonate hardness, that is calcium sulfate or calcium chloride. So these are the 4 reactions in the last stage. If we add lime, that is calcium hydroxide, in the magnesium sulfate, then it will get the precipitation of magnesium hydroxide plus calcium sulfate. Again, if we add the soda or Na2CO3 in the calcium sulfate, further we have to add the soda or Na2CO3 in the calcium sulfate, then it will give us CaCO3 calcium carbonate precipitation and Na2SO4. Similarly, for magnesium chloride, we have to add the lime in the magnesium chloride. It will give us magnesium hydroxide precipitation plus calcium chloride, and further in the calcium chloride, if we add the soda, that is Na2CO3, which gives calcium carbonate again, in the precipitation form, plus 2 NaCl, that is sodium chloride. So this is how the lime soda method is used to reduce to soften the water. Okay, so now we'll see or move towards the second method, that is ion exchange method. Okay. Now ion exchange is a displacement of one ion by the another ion. In the process of softening, the calcium and magnesium from the water are removed on the ion exchange material which is used. So the ion exchange material used is zeolite or the synthetic resin. These are cation exchange material. The solution from this enters into the water, and calcium and magnesium from the water enters into these materials, and after the exhaustion of the capacity of these materials, these can be regenerated by the sodium chloride solution. Okay. So what basically this method is about, basically the softening will takes place by the ion exchange method, and the ion exchange material in this case is used, it is known as zeolite or the synthetic resin. So synthetic resin are the cation exchange materials. We know that the anions are the positively charged ions and cations are the negatively charged ion. Positively charged ion will attract towards the negatively charged ion, hence the calcium and magnesium will get separate from this, and by using the synthetic resin or the zeolite, and the water will get softened. Here you can have a look on the image. The resin or the zeolite material is used as a membrane or the material for the ion exchange method, or to get calcium and magnesium get separated from each other by using this resin or the zeolite material. Now we will see about the desalination process. Desalination is the process of reclaiming the sea water by removing the dissolved salts from it to produce the fresh water, or it is of the it should be a potable water quality. This process is known as desalination process. The processes of desalination of sea water envisage either removal of good water from the solution or the removal of salt from the solution, leaving the good water behind. So in the both way the desalination can be done. There are two methods of desalination. First method is the reverse osmosis method, and second method is the electrodialysis method. So reverse osmosis method, I think many of us are familiar with the reverse osmosis method. Many of you may have the RO system in our house to soften the water or to clear the water. The same we will see in the next slide, how this reverse osmosis can be done. So we will go one by one. We will see the reverse osmosis. First we have to know what is mean by osmosis. Okay. The osmosis is a natural now we will move forward to the desalination. The process of reclaiming the sea water by removing the dissolved salts from it to produce the fresh and potable water is called as a desalination. So desalination means what? So it is used for the removal of the salt in the water. So it is especially used in case of the sea water. There are two methods of desalination. First method is the reverse osmosis method, and the second method is electrodialysis method. So in the reverse osmosis, first we will go one by one with the reverse osmosis method. Osmosis is a natural phenomenon in which the water moves from a higher concentration of water that is less sugar or salt dissolved in it, to the lower concentration of water that is more salt dissolved in it across a semi-permeable membrane. So this means that the water can cross a selectively permeable membrane from a dilute solution or which is less dissolved in it to a concentrated solution which is more dissolved in it. So this is called as a osmosis, and the reverse of the osmosis is called as a reverse osmosis process. Here is the diagram by which the reverse osmosis concept can be get very clear. You can see in the left side there is a salt water and the right side there is a fresh water, and between these two types of water there is a semi permeable membrane. The semi permeable membrane here we are using to reduce the salt contents in the water. So when the pressure applied to the sea water or the salty water is greater than the osmotic pressure, then the water from solute diffuses from the solution through the membrane to get fresh water side. This is the reverse osmosis process. Thus reverse osmosis is the forced passage of water through a membrane against the natural osmotic pressure to accomplish separation of water from a solution of dissolved salts. The pressure applied varies between 300 to 1500 psi with a typical range of 600 to 800 psi. The quantity of product water is 70 to 90% for a feed of brackish ground water and about 30% for a feed of sea water. So the reverse osmosis process or units are very common, which we can get in the market very easily at the consumer level. So many of us are familiar with the reverse osmosis process. Now the second process is electrodialysis process. Electrodialysis refers to the transport of the ions from a salt solution through ion exchange membranes as a result of an applied electric field. So in case of water softening methods, we have seen the ion exchange method. The ion exchange method and electrodialysis method are quite similar, with the only difference is the ion exchange membranes in case of electrodialysis will take place as a result of the applied electric field. So there are anode and cathode will be there to develop the electric field in the apparatus. The electrodialysis stack consists of a number of cation and anion exchange membranes arranged alternatively. The saline field is fed through the manifold in the alternate compartments. The cations and anions migrates towards the cathode and anode through the cation and anion exchange membranes respectively, leaving the feed depleted in salt while neighboring compartments become concentrated. So we are quite familiar with the cathode and anode, the positively charged electrode and the negatively charged electrode. So here is the diagram or pictorial representation of the electrodialysis process. Here you can see there is a negatively charged electrode, and the positively charged electrode is also there with the membrane, and we know that salt, the chemical formula of salt is NaCl. So Na or sodium ions are positively charged, which will attract towards the negatively charged electrode, and the chlorine ions are negatively charged, they will attract towards the positively charged electrode, and hence the water will get free from the salt, and then will get the fresh water which is free from the salt. Now we'll move towards the last topic of today's discussion, that is fluoridation and defluoridation. The fluorine is the 13th most abundant naturally occurring element in the earth's crust and is the lightest member of the halogens. So though the fluorine is the 13th most abundant naturally occurring element, it does not occur naturally, but it will occur or it will found as a fluoride mineral complex. So water is frequently referred as a universal solvent because it has the ability to dissolve almost all the substances that comes in its contact. So when the fluoride comes into contact with the water, it will get dissolved, and the elements such as fluoride which is dissolved in the water can cause the toxic effect on the human body. So, the fluoride up to the certain limit it is necessary for the human body or the to reduce or to avoid the tooth decay, but it should be there in a certain quantity in the water. So, fluoridation means what? Water fluoridation is the process of adding fluoride to the water supply, so the level reaches approximately 0.7 parts per million or 0.7 milligrams of fluoride per liter of water. This is the optimal level for preventing the tooth decay. So, fluoride is necessary, but it should not reach its limit, or the quantity of the fluoride should not be greater than the 0.7 ppm or 0.7 milligrams per liter of water. So, water fluoridation is the precise adjustment of natural fluoride concentration in a public water supply up to the level recommended for preventing tooth decay. So, this is what the fluoridation is. Now, the excess fluoride which is present in the water, that we have to remove it, and the process of removing of the fluoride concentration in the water is called as defluoridation, in order to make it safe for the human consumption. The methods of defluoridation are we can reduce or remove the fluoride by using the defluoridation agents. The activated carbons prepared from various materials can be used as a defluoridation agent. The materials such as calcium phosphate, bone charcoal, synthetic tricalcium phosphate, etc., may be added for the removal of excess fluoride content in the water. Okay. Now we'll just orally discuss what is meant by bone charcoal method. The bone charcoal is a blackish porous granular material. The major component of the bone charcoal are calcium phosphate, which is present 57 to 80%, calcium carbonate is 6 to 10% in the bone charcoal, and activated carbon is 7 to 10% in the bone charcoal. In contact with the water, the bone charcoal is able to a limited extent to absorb a wide range of the pollutants such as color, taste and odor components. Moreover, the bone charcoal has a good ability to absorb fluoride from the water. This is believed to be due to its chemical composition, mainly as a hydroxyapatite, that is Ca10PO4 6OH twice. So, where one or both the hydroxyl groups can be replaced with the fluorine. Okay. So, I will just tell you the reaction which happens in case of a bone charcoal. Ca10PO4 6OH twice, which is the chemical formula of hydroxyapatite plus 2F, means 2 fluorine, gives us Ca10PO4 6F2 plus 2OH twice. So, in this way we can remove the fluoride, excess fluoride concentration which is present in the water. Okay. So, apart from this, there is a method which is very well known, and it is invented in the India, and the method of defluoridation is called as a Nalgonda method. This process was developed in India by the National Environmental Engineering Research Institute, NEERI. In this process, aluminum sulfate is used for coagulation, flocculation, sedimentation, where the dosage is designed to ensure fluoride removal from the water. Aluminum sulfate, that is Al2SO4 thrice 18H2O, is added to the water and efficient stirring in order to ensure initial complete mixing. Aluminum hydroxide microflocks are produced rapidly and gathered into the larger, easily settling flocks. Due to that, specific gravity of particles increase, therefore the mixture is allowed to settle. During the flocculation process, many kinds of microparticles and negatively charged ions, includes fluoride, are partially removed by electrostatic attachment to the flocks. So, this is how the Nalgonda method takes place or works for the removal of the fluoride concentration which is present in the water. So, this is all about the today's topic of water softening methods. So, we will just summarize what we have today or what we learned today. First, we have learned about what is meant by water softening, why the water softening is necessary, what are the different methods of water softening, what is meant by desalination, then what are the different methods of desalination, what is meant by fluoridation and defluoridation, why the defluoridation is required, what will happen if we don't go for the defluoridation. That is all with the today's topic, that is softening of water. Now in the last slide, there is a diagram or schematic diagram of water treatment plant. So from the unit number 2 to till now, we have gone through the phases of the water treatment, starting from the source of water, then intake well, screening, primary sedimentation, secondary sedimentation, coagulation, after that filtration, chlorination and water softening. So till now we have reached to the water softening, or we have finished today water softening, and this is intentionally I have put this slide into this presentation because I wanted you to summarize the things, how the water get traveled through the various units in the process of water treatment. So we have reached up to the water softening method, and after the water softening, the water will reach, or water is transported towards the elevated service reservoir, where the water gets stored for the distribution and further distribution to the consumer level. So in the next lecture we will see some water distribution systems and how the what are the different factors or the requirement considered in the design of distribution system, and what are the different types of elevated service reservoirs, that we are going to see in more detail in the next lecture. So I hope today's you all have understood today's topic. If you have any difficulty, you please contact me or drop a message to me. Thank you very much.